This week on Maker Update, a mechatronic egg-stealing force wizard, physical control for your PC audio, tips for solder wicking, and counting your screws before they fasten. Hello and welcome back to Maker Update, the show where we know the difference between a screw and a bolt. I'm Tyler Weingartner, it's hot and we're in the depth of summer, and I hope you're keeping cool and staying creative. We've got a wonderful show for you, so let's get it going with the project of the week. It's still a work in progress, but you have to check out this animatronic Grogu model being built by Adam Savage and a few friends. And that's really the lesson here. Some projects are just bigger than you can tackle alone, but that's no reason not to take them on. In fact, maybe that's the best reason to build something like this. This project started its journey as a college project by animatronics designer Matthew Winchell, as a means to grow his skills as an engineer. He came to meet Adam Savage and a collaboration was born into making the version 2 you see here in this video. Coming along for the ride was sculptor Ralph Sutter, who made the skin for the face. Unsurprisingly, there's a ton of cool tech underneath that skin. To make the ears animate, they use just 2 servos for both ears. To pull this off, each servo is connected to a pulley system that allows it to control one axis back and forth for both ears. The other servo handles the second axis. It all works through this manifold of cabling from the back up to the pivot points for the ears. Another great tip is how 3D printing helped Adam Savage machine these small brass parts. Adam was given blueprints for the parts, but also a set of STL files. Because of that, he was able to print the parts to better visualize what the drawings were trying to communicate. It was also fascinating to learn how the skin is glued onto the frame and how that will vary from character to character. This may be a work in progress, but the motion is already looking incredible and amazingly lifelike. There's still some programming to work out to make the motion smoother, and then they need to migrate all the electronics into the 3D printed body. I expect we'll see another video of that further down the road, but there's so much valuable information in this episode, it was too good to pass up. More projects. When your business changes, your tools have to change with it. That's the story behind this 9-axis fastener counter created by Christopher Helmke. His 3D printed parts business also sold small packages of pre-counted fasteners to a few select customers. And when that part of his business blew up, he needed a way to scale. The process begins by loading in a crate full of fasteners. It moves forward while the counting mechanism swings down over the top of it, locking it into place. The contents of the crate are then emptied into the counter. But the counting mechanism itself is wild. It picks up a random number of screws and, through a series of movements, arranges them into a single row. They're then lifted in front of an optical scanner, which counts the fasteners and notes their position. And then finally, the desired number are lifted past this slanted gate into the buffer bin. The parts are then counted again using a more rudimentary method to rule out any discrepancies. The amazing thing is that this can count any size and length of fastener. It's an incredible piece of engineering. On his YouTube channel, Paul Junkin has a video about how he built this 2-axis, remote-controlled paintball turret. This is a fairly simple construction of aluminum extrusion, 3D printed gears, and stepper motors. But he's using solenoids to pull the trigger, so he's able to convert the paintball gun to fully automatic with just a bit of code. But the real revelation, for me at least, is how easily he was able to connect an Xbox controller to the ESP32 to control everything. It uses Bluetooth, and it likely introduces some latency and a shorter range, but this really lowers the barrier for remote-controlled projects. From Hackaday, I learned about this external audio mixer for your computer by MakerVibe. Windows has some really powerful volume control for different sources, but they're buried deep within menus. He's using the Xiao ESP32 S3 as the brains and connecting to his computer via Bluetooth using the same BLE gamepad library that's likely used in the last project. The software controlling the volume is called Voicemeeter Banana, and the hardware from the device communicates with that software via a custom Python script running in the background. You can find all the resources to build your own down in the description. Now for some tips and tools. I admit solder wicking is one of those skills I've never gotten the hang of. Thankfully, nanofix has a video to help anybody who's ever had trouble with it. He leads with likely the best tip first. Cut off a tiny piece instead of just using the whole roll. Because the wick conducts heat really well, all that heat from your iron is getting lost in the whole spool. And then use tweezers to grip the wick. Also, cut your wick at an angle so you have a fine point for detail work. Tons of great tips here to level up your skills. Valenti Felder shares a few of his tips on making ball joints. These are instrumental in making armatures for stop-motion films. He talks about the different types of steel balls you can find, even though he prefers to make his own. He has a high-end machinist lathe, but he also shares how to do this on a drill press. He also shares some of his soldering techniques, including the cheap torch that he uses, the different types of solder, and flux. Plus a few techniques to get the best results. Via Hackaday, I also found this guide by Julius makes to using various PCB parts and products to elevate your Greebles game. There's actually a ton of great tips here for different kinds of parts, but tips like using these BGA solder templates is really fun. He also shares some great tips for making your own custom PCBs that are just visually interesting instead of functional, including cutting slots to allow for backlighting and how to place traces that aren't functional but just look cool. And finally, by Cheung, we have a video about an inexpensive die cutting machine. Kevin is obsessed with upcycling ready-made materials. He's already designed this tool for cutting the aluminum from drink cans into flat sheets. And in this video, he shows what you can do with them. He shows how to use the machine, the results you can get from it, and how to order your own custom-made dies for your own designs. It's cool stuff. For this week's DigiKey Spotlight, Zach, the bite-sized engineer, is embarking on a project to create a PCB tile-based board game. He wants the tiles to be magnetically interlocked, and those magnets, or the tiles, should be able to pass data from one to another. For this, he's using magnetic pogo pins. A lot of the video is basic game design stuff, figuring out which shape of the tile he wants to use through prototyping, seeing how they fit together, and how they come apart. Each tile will also have its own microcontroller. His insights on the PCB design for a project like this are also great to take in. Alright, and that is going to do it for this week's show. A reminder, as always, you can get more info about every single one of these tips and projects by following the links down in the description. While you're there, leave us a comment, give us a thumbs up, and hit subscribe so you won't miss the next one. Another reminder that Donald and I will be at Open Sauce this weekend, and we'll be shooting a show there, so hopefully look for that next week. Huge thanks, as always, to DigiKey for making this show possible and to you for watching. Take care. We'll see you soon.